Today we are going to discuss the topic about equivalent circuit of induction motor. The equivalent circuit of single phase induction motor can be developed by using the double field revolving theory. By using the equivalent circuit performance of single phase induction motor can be obtained. The single phase induction motor can be made single stator winding and two imaginary rotor. The developing torques of single phase induction motor are two torques. One is forward torque and another one is reverse torque. Single phase induction motor iron or core loss is taken as of actual rotor impedance referred to stator. The resultant forward stator flux produces forward air gap flux. Then this flux induces the voltage in rotor Vf. The impedance is R2 dash divided by 2s plus jx2 divided by 2. The backward flux induces current in the rotor at the frequency of 2 minus s. The corresponding rotor MMF rotates in the air gap at synchronous speed in backward direction. First one is equivalent circuit still based double field revolving theory and equivalent circuit at any slip diagram. From this equivalent circuit, forward impedance ZF is greater than the backward impedance ZB, and forward induced voltage Vf is also greater than Vb. Performance analysis. The equivalent circuit of single phase inductor motor. First diagram is transformer equivalent of single phase motor with rotor stationary, and second one diagram is a rotating field equivalent circuit of single phase motor with rotor stationary, and third one is a rotor field equivalent of single phase motor under running condition. Three different types of equivalent circuits of single phase induction motor. The performance analysis of equivalent circuit is can calculate the stator current, input power, developed torque and efficiency for particular speeds. To simplify the equivalent circuit is the air gap for the forward backward fields are given by air gap power for forward field BGF is equal to of Im square Rf. Air gap power for backward field PGP is equal to of Im square Rb. Here Im is a main winding current, Rf and Rb is a real part of complex number of impedance Zf and Zb. The torque produced by the two fields can expressed as torque is formula is 1 divided by omega, and it replaced by 1 divided by omega as PGF. TP is equal to, first one is forward and TP means backward, 1 divided by omega is PGP, and resultant torque developed is T is equal to TF minus TP. TF means forward and TP is backward, and the above two values will be substituted on this equation. So T is equal to 1 divided by omega s is common, so common remaining term is PGF minus PGB, and Im square divided by 2 omega s, this value is substituted on omega values, then Rf minus Rb. Rotor copper loss corresponding forward field is SPGF, and rotor loss corresponding to backward field is 2 minus SBGP. Rotor copper loss SGPF plus 2 minus SGP, and cross mechanical power PM is equal to 1 minus S omega ST. Then PM is equal to 1 minus S omega S value substitute PGF minus PGP, and PM is equal to 1 minus S PGF plus 1 minus 2S PGP. Okay, thank you.